Why not?
Is that?
All right, let's take the derivative of this function. Now we're going to have to do the chain rule for this. So the chain rule says take the derivative, y prime equals the derivative of the outer function, which is u to the negative 2. So it's take the negative 2 down, negative 2, and then subtract 1. So that's going to be all to the negative 3, and leave the stuff that's inside the argument unchanged. So x cubed minus 7 over x. And then multiply it by the derivative, I'll do this in purple, the derivative of the inside. So the derivative of the inside is, now notice that this right here is 7x to the negative 1. So let me rewrite that. The inside is really x cubed minus 7x to the negative 1.
Okay.
So the derivative, just use the power rule for this. 3x squared plus, I'm bringing that negative 1 down, so it becomes a positive 7x to the negative 2.
Okay.
Now, for a lot of people, the hardest thing is to clean this thing up correctly, so let's clean it up. So this is going to be negative, let's see, what am I going to have to do? I'm going to have to take this, let me just rewrite it so we can see it better. Negative 2x cubed minus 7 over x cubed
That's the first part.
times, yeah, that's the first part, times 3x squared plus 7 over x squared.
Okay.
Let's see if this can clean up at all. So this whole thing really, right here, is just multiplying the top, the numerator. So let's clean that up. Negative 2 times 3x squared plus 7 over x squared all over x cubed minus 7 over x quantity cubed.
Do you distribute the two, or do you just?
You can distribute this too if you want, but I'm just looking at it. Before I distribute, I look at it to see if there's an easier way for me to simplify anything. And probably, this is probably sufficient just to leave it like this.
Okay.
One other thing you could do, I suppose, is you can rewrite, let me change colors here so you can see what I'm doing. You can change this to x squared. You can multiply that by x squared over x squared.
To get rid of the.
And then this x squared here is going to go into the bottom. So what would happen is you would have x squared all the way in the denominator, because it's like you're factoring out the x squared. It's all the way in the denominator, and it's x cubed minus 7 over x quantity cubed. And then in the numerator you would just have, I'll just go ahead and distribute the negative 2 in now. Negative 6x to the 4th minus 14.
Okay.
So that looks, and the reason this is the way, maybe the best way to write is because then it's easier to identify what your critical points are. Set the denominator and numerator equal to 0. Obviously you can't plug in 0 for x, so that's one of your critical points because it would give you a 0 in the denominator. But then you can then set this thing equal to 0 as well, and then set the top equal to 0 as well.
To get x squared on the bottom, we just multiplied everything by x squared.
Yeah, so what I did here, if I were to expand on what I did right here, I got common denominator, and then I wrote it like almost like a complex fraction. And remember, if you have 1 over x squared all over x to the 3rd, let's say, this is like x to the 3rd over 1, so it flips, and it becomes 1 over x to the cube. So really, these just end up being in the denominator.
Okay.
And it just becomes 1 over x